In this segment, we're starting our unit on trigonometry. So trigonometry is going to be a long unit, a large amount of material. However, this is the last topic that we have to do in pre-calc. So we're going to be on this topic for the next month until we're at the end of the semester. And I am going to start with the assumption that you really just barely remember anything. So I hope I don't insult anyone's intelligence in the first couple lessons that I'm going to present on this topic, because I'm going to start very basic. And I've learned in my years teaching that, whenever I assume people remember things from the past, I've kind of learned that that's just not a good assumption. So I always start with this assumption that people don't remember anything. And so if this lesson and the next lesson are a little bit too basic for you, bear with me. I promise it will get harder. So anyway, with the trig functions, and let me point out to you the key word here, function. Okay, if you can learn to understand that trig is a function, all right, that I put something in and I get something out. I have input and output. That's what a function is. All right, as long as you can understand trig as a function, that'll really break down some barriers to understanding how to work with these functions. And there are 6 trigonometric functions that we're going to study. I'm sure you've heard of the first 3. All right, probably you've at least heard the last 3 mentioned, although perhaps you've never studied them in depth. But I'm sure you've heard of sine, cosine, and tangent. And these functions all have reciprocals. Okay, and so the reciprocal of cosine is secant. Okay, and the reciprocal of sine is cosecant, and the reciprocal of tangent is cotangent. So as long as we know about how to work with these functions, it's very easy to take what we know about these functions and then just extend that a little bit to the reciprocal functions. So anyway, I did some copying and pasting from around the internet and found some of my favorite visuals. And you would have done these probably as early as 8th grade. So again, I know you've done these before where you work with the right triangle, right? And you've probably learned SOHCAHTOA. That's the most common acronym. There's other cute little sayings that go with this. I mean, I remember from my middle school years, not that this is a cute saying, but they used to say, some old horse caught another horse taking oats away. That was an expression I learned. There's others. So anyway, when we are working with these trig ratios, right, sine of an angle, so we input the angle, right? That's what we input into the function. And then what we output is the ratio of the opposite leg to the hypotenuse. And cosine, right? I input the angle. So this angle here is my input, and I output the ratio that is the adjacent over hypotenuse. All right, so when you're writing your trig functions, it's very important to always include the angle. All right, so you never want to just write SIN, right? Unless you're in church, SIN, right, has no meaning mathematically. Okay, so the trig functions have to operate on an angle. Okay, if you're referring to just the sine function, then you can write it out like that, right? The sine function. But you don't ever want to just write y equals SIN, right? Because then you've got this function and it's like you've got no input slot, right? So right here, this is your slot for input and you need to put the angle. I might name the angle theta, that's very common. I might name the angle x, right? So I could have y equals sine x. Other common names for angles, we use the Greek letters. I'm going to be using those later in this segment, alpha and beta, right? Those are common choices for representing angles, all right? But there's no such thing as a trig function without a place for input. The input is always an angle, when I'm working with trig functions. So again, this is a summary of the information I've already presented. I just found it in a different representation on the internet. So if you like to have a table form better, and then I also wanted these words completely spelled out for you. So here's the whole entire term, cosecant, and then the reciprocal of cosecant is sine. Okay, and then here's the abbreviation for it. Honestly, never in my entire life, and I've been doing math for a long time, I've actually never seen this abbreviation for cosecant. Not saying it's not used, I've just never seen it in all my like 25 years of being involved in math. So anyway, these are things that I'm going to expect you to know. And let's take a look at the first example. So in this first example, although one comment that I want to make about the meaning of, say, sine of 30 degrees. Okay, what does that really mean? Okay, so here's the 30-degree angle, and sine is defined as the ratio of the opposite leg to the hypotenuse. And one of the link that I have right below this video that says the literal meaning of the trig ratios, it shows this in an animated way. And I really like this because it helps you understand that, you know, what this really meant. And if you ever have the opportunity to look at the history of math historically, when you look at things in math and how they developed and were derived, everything goes back to a geometric perspective when you look at things historically. All right, so if I were to geometrically look at what does the sine of 30 really mean, I could take this opposite side, okay, I could measure this off, and if I measured it off, I would come over here and I would be able to place this red length here twice. Okay, so there would be two of these lengths over on this side. And so the website that I gave you, you actually click on this segment and then it pops it over to the other side twice so that you can see that happening. So I really like that representation. I feel like that helps you understand the meaning of these trig ratios. So anyway, let's apply our SOHCAHTOA in these examples. Okay, so sine of 30, as we just said, is opposite over hypotenuse. All right, and I'll do a couple with you, and then I'm going to have you pause and try the others yourself. Tangent of 60. So tangent of 60, tangent is opposite over adjacent. Okay, opposite, of course, is relative to the angle you're looking at. Right? The opposite side is different whether I'm referring to the 30 or the 60, but I'm hoping you got that figured out back in either middle school or high school where you were first learning these. All right, so opposite over adjacent. Well, adjacent is just 1, so I'm just going to write that as radical 3. And then we have some of these reciprocal functions. Okay, so for example, this is the reciprocal of sine, right? So if sine is opposite over hypotenuse, then in reference to the 30-degree angle, cosecant of 30 degrees would be hypotenuse over opposite. All right, and so hypotenuse over opposite would be 2 over 1, all right, or just the reciprocal of sine of 30. So let's do this. I'm going to stop the video and I'm going to ask you to fill in, don't do this last row yet. We haven't talked about that. So fill in these remaining values and then we'll restart the clip in the next segment where I'll show you those answers, and then we'll move on and start talking about some inverse trig. All right, just like we can find the inverse of other functions, right? We can switch our x and y and find an inverse function for trig. All right, so we'll talk about that in the next segment.